All right, class, next section, 8.5, using properties of trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, and the parallel sides are the bases. So we see our picture here. Our bases are on the top and bottom in this picture. We can see that those are parallel, and then the legs are the two non-parallel sides. So a trapezoid has two pairs of base angles, and for this example, angle A and angle D are one pair of base angles, and angle B and angle C are the second pair. And then your non-parallel sides are the legs, like we said. So on your quadrilateral family tree at the back of your notes, we can fill in information for our trapezoids. So a trapezoid characteristics, one pair of parallel sides. One pair of parallel sides. And then the other characteristic of a trapezoid is that the mid-segment is 1/2 the sum of the two bases. The mid-segment is 1/2 the sum of the two bases. We'll talk about what a mid-segment is. So 1/2 the sum of the two bases is that mid-segment. Now, along with a trapezoid, there can also be isosceles trapezoids, which is just a little bit more specific than a regular trapezoid. And our characteristics of an isosceles trapezoid is that the legs are congruent. So not the bases, not what's parallel, but those non-parallel sides, which are the legs are congruent. And then the next characteristic is that each pair of base angles are congruent. Each pair of base angles are congruent. And then the last characteristic of an isosceles trapezoid is that the diagonals are congruent. Don't get that mixed up with the rectangles characteristic where diagonals are congruent. But this is specifically for isosceles trapezoid. The diagonals are congruent, each pair of base angles are congruent, and the legs are congruent. And then we'll come back to kites in a moment. So don't worry about writing down that information. We just did that on our family tree. But we can see a picture here of what isosceles trapezoids would then look like. We can see our two congruent legs. Our base angles would also be congruent. Those would be congruent with one another, like that. And you still have your parallel bases. Now the mid-segment, we did mention a mid-segment, that would be a line drawn right across the middle of the trapezoid. Now in an isosceles trapezoid, those would be congruent. But in a regular trapezoid, the left side segments, those would be congruent, but then the right sides would be a little bit different. but that would be a mid-segment, so a line going right through the middle, connecting the two legs that are parallel with the bases. So it's parallel with the bases, and that's the mid-segment is 1/2 the sum of the two bases added together. So if I added up the top and the length of the bottom divided by 2, that would be the length of this mid-segment. So using properties of isosceles trapezoids. So if we have a shelf fitting into a cupboard in the corner of a kitchen, and an isosceles trapezoid is in the corner of a kitchen is an isosceles trapezoid. So we want to find the measure of angle N, L, and M. So I know, because it's an isosceles trapezoid, that my base angles are going to be congruent. So if angle K is 50, so is angle N. So angle N is 50 degrees. But then angle L and angle M are clearly different angles. Like you can look at the picture and tell, all right, if K and N are 50 degrees, those are two acute angles. Looking up at L and M, they both look like obtuse angles. That's because they are, M is supplementary to N. Notice they are consecutive angles. We got our two parallel lines and a transversal, and they're consecutive interior angles, which means they're supplementary. So I would take 180 minus 50, and my other two angles are going to be 130. So L is congruent with M, and they're both 130. Now that's just with the isosceles trapezoids. In a regular trapezoid, your side angles or your consecutive interior angles are still going to be supplementary, but that they're not going to, the base angles aren't going to match up. The base angles are going to be different. So even though your left side will still add up to 180 and the right side will still add up to 180, the bottom will not be the same and the top will not be the same in a normal trapezoid. All right, the mid-segment theorem for trapezoids. The mid-segment being of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if we look at this example, we have our mid-segment drawn right through the middle. We can see that it splits our legs into two equal parts. That's congruent with that. And that over there is congruent with that. And each of those segments are congruent with each other because we know it is an isosceles trapezoid. So we want to find the measure of angle B and find the length of PQ. So let's first look at angle B. Angle B is up here at the top right. I know that my base angles are congruent, so angle C is 75. And that means that angle B and angle C are supplementary, so I can subtract 75 from 180. And that'll give me angle B. So I know angle B is 105 degrees. Angle B is 105, and then I need to find the measure of PQ. PQ is our mid-segment. I know what my bases are. I have a base of 25, a base of 35. I need to add those together and divide by 2, because PQ, our mid-segment, is 1/2 the sum of the lengths of the bases. So the sum means I need to add. So 35 plus 25 gives me 60. And then I will divide by 2. So PQ is 30. PQ is 30 and angle B is 105. Notice for that mid segment, you're just finding the average of the two lengths of the bases. Right, now a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. So let's go back to our quadrilateral family tree and fill in our information on kites. So our characteristics for kites, two pairs of consecutive sides congruent. Two pairs of consecutive sides congruent, where consecutive is next to each other. The second characteristic is that diagonals are perpendicular. Diagonals are perpendicular, so don't get that confused with rhombuses. They do have the same characteristic as a rhombus. And then the last one, exactly one pair of opposite angles congruent. Exactly one pair of opposite angles congruent. What we mean by exactly one pair is that only one pair of opposite angles can be congruent. Only one. All right, so let's go back and look at these examples for kites. So in our picture, we can see our consecutive sides that are marked congruent. So the ones on the left are congruent with each other, and the ones on the right are congruent with each other. Now the other characteristic of a kite was that exactly we have diagonals are perpendicular. So that would be, we're drawing our diagonals, and they're perpendicular, means they form right angles. And then if I were looking at the angles, exactly one pair of opposite angles are congruent. It would be those angles. The ones in between the different length sides. The ones that are included between the sides that are different lengths. So this angle on the left and the angle on the right are different sizes. So they will not be supplementary with their consecutive angles. But those opposite angles are congruent. So let's use some of those properties to help us figure out. And in this case, let's find the measure of angle Q. So in this diagram, we see that PQRS is a kite. We want to find angle Q. So we can see angle P and angle R are not the same, but I know it's a kite, so I know exactly one pair of opposite angles are going to be congruent. Now it is a quadrilateral, and all angles of a quadrilateral need to add up to 360. We used our n minus 2 times 180, n being four-sided figure, so 4. 4 minus 2 is 2. 2 times 180 is 360. I know all my angles need to add up to 360. So I can subtract 83 and I can subtract 41. And that gives me 236. So both of those angles, Q and S, need to add up to 236. And since they're the same, I can just divide that by 2. So angle Q equals 118 degrees. And so does angle S. Both of those equal 118 degrees. So we took 236 and divided by 2. So if we need to find the value of x, knowing our properties of trapezoids, I guess all these are right here are trapezoids, want to find our value of x. So looking here, it's just showing us information about our diagonals and the segments of our diagonals. We do see it's an isosceles trapezoid. Our legs are congruent. And because our legs are congruent there, we know this is an isosceles trapezoid. We know those are our bases and those bases are parallel. So with our diagonals, what do we know about diagonals with an isosceles trapezoid? We know that they're congruent. So 5x plus 2 plus 21 is going to equal 3x plus 6x minus 5. So remember, we got to combine. The diagonal is that entire length, not just the smaller segments. So that entire length in blue is 3x plus 6x minus 5. And that's going to be equal to our other diagonal, which is 5x plus 2 plus 21. Then we can just combine all of our like terms and solve for x. You get 9x minus 5 equals 5x plus 23. We can subtract 5x from both sides. Then we'll add 5 to both sides. Gives me 4x equals 28. Divide by 4. So x equals 7. So once we're able to identify that as an isosceles trapezoid, then we're able to use that information that we know about isosceles trapezoids to find our value of x. So looking at this trapezoid, we see it's a quadrilateral. It's a trapezoid because our bases are parallel. Got the little arrows there. And we want to know what the base lengths are, or we want to know what x is. 18 is our midsegment. I know that's a midsegment because it separates my legs into 2 equal parts. So those 2 segments are congruent, so I know that this midsegment is bisecting that leg, and it's also bisecting the leg over here. So it is a midsegment. And our midsegment is half of our legs, or half of our bases added together. So I know that our bases added together need to equal 18 times 2. I need to double my midsegment, which gives me 36. So x plus 3x equals 36. So I get 4x equals 36. Divide by 4. And x equals 9. And for our last example here, we want to find MN in this trapezoid. So MN is our mid-segment. So we just need to look at our bases of 30 feet and 12 feet. We add those together. Which gives us 42. And then divide by 2, because MN is half of the sum of those added together. So divided by 2 is going to give us 21. So MN equals 21 feet. All right, that is it on the notes. Make sure you do your homework.